Hello everyone, welcome to today's class. Today we are going to look at modular arithmetic. Okay, so let us first of all look at the concept of modular arithmetic. Okay, what is the concept of modular arithmetic? Modular arithmetic is almost like when you are trying to solve a problem in number base. Not exactly number base, but almost like the way we solve problem in number base. Though in modular arithmetic, we can have negative numbers. Okay. Now, how do we solve problem, or what do we mean by representing a number in a certain modulo? What it means is that, for example, if I have 5 and I want to represent this 5 in modulo 2, what does that mean? I need to keep sharing 5 in 2s, and I will get the last digit. The last digit is the remainder is the number that will give me the modulo of 2. Now, what am I trying to say? If I have 5, that will give me 2, 2, 1. So when I take this one out, 5 will give me 1 in modulo 2. So what does that mean? When I share my number in the certain modulo, the remainder will give me my answer. Okay, now what does that mean? It means that numbers in base 2 are also what we call the integers in modulo 2. Numbers that you find in base 8, that is what you have as the integer in modulo 8. So what does that mean? Whenever I'm taking a modulo of a number, my answer will not get up to the number. What am I trying to say? If I'm looking for modulo 5, it simply means that my answer can either be 0, 1, 2, 3, or 4. Okay, that is the integers in modulo 5. So what I have here is a kind of samples or examples of integers in a certain modulo. So when we say modulo 5, that means we expect to have integers, digits or answers like 0, 1, 2, 3, and 4. If I have integers in modulo 7, I'll have from 5 to 6. And if I have integers in modulo 3, I have from 0 to 2. Okay, that means if I have, let's say I'm trying to get my number in modulo 8 or modulo, let's say modulo 12, that means the highest integer I'm going to have as my answer is 11. Okay, that's 0 to 11, which is about 12 digits also. So this is the little idea about modulo. Now, in real life situation, do we apply this modular arithmetic in some places? Yes, we apply modular arithmetic in anything that have a certain routine. For example, run the clock. Okay, if you see the face of the clock, you will notice that the clock starts from 12, goes round and come back to 12, and start up again and goes round and come back to what? 12. So any event that happens periodically is an application of modular arithmetic. When we finish solving the solving problems in modular arithmetic, by the time we move to real life situation in modular arithmetic, you see where you can actually apply modular arithmetic. Let me just give you an example. Let's say the time now is 6 p.m. and I'm asked what will be the time in next 852 hours. I don't need to start calculating 24, 24. No, I will use my modular arithmetic in modulo 24 to get my value. Okay, so this is where we apply modular arithmetic in real life situation. Okay, but before that, let us carry out our modular arithmetic and see how we can be able to find the modular arithmetic of a number. In finding the modulo of a certain number, there are different ways of doing that. Especially if the number is a positive number, we have more than 2 to 3 ways by which you can be able to find your modulo. But what of when the number is negative? Let's take example. of getting our numbers in a certain modulo that will help us to now know if there will be difference between a positive number and a negative number. Let's take example 1. So in the first example we have here, we want to express 13 in modulo 5. Okay, like I said, if the number is a positive number, there are many ways we can do that. So I'm going to show you different ways of doing that. Then I will tell you which one of them is that you can actually use both for positive number and negative number. So let us do the simplest method of all. The first method is very simple. If I have my 13, all I need to do to keep sharing my number in fives, okay? If I keep sharing my number in fives, then the remainder is my modulo. So what does that mean? 5 plus 5 plus 3, okay? 5 plus 5 plus 3 will give me what? 13. Therefore, 13 is equals to 3 modulo 5. Okay, so these are the first method that one can use to find modulo of a certain number. Now let us look at another method you can use, which is also close to this. Now the second method we are going to use is close to this. If I have 13, I'll ask myself 5 times which number will give me a closest value that is less than 13. 5 times which value or which number that will give me a closest value that is less than 13. So I will say 5 times a number which will give me a closest value to 13. That's what? 2. Then plus, what do I need to add to that to get 13? 3. So that will give us 3 modulo 5. Okay. Now the last method we divide as if we are converting 13 to base 5. But in this case, we only divide once, okay? So if I have 13, I will divide it by 5. That will give me 2, remainder 3. Therefore, 13 equals to 3 modulo 5. So you can see 3 different ways that we have used to get our modulo. But which of these ways, which of these methods that is also applicable in negative numbers, okay? In negative numbers. This is the one that we are going to be using, okay? And this method can also be likened to use of calculator in solving this problem. Now, how do you use your calculator to do this problem? Just press your 13 and keep removing your modulo till you get a number that is less than your modulo. Okay? For example, you press 13 in your calculator, minus 5, that will give you 8, minus 5, that will give you 3, which is less than the modulo. So your answer will be 3 modulo 5. It can also be used in negative numbers, but in negative numbers, instead of subtracting 5, we'll keep adding 5. Okay, so let us solve more examples on modular arithmetic. So we are trying to find 34 in modulo 15. So it's very simple. All you need to do, 34 equals to 15 times which number will give us closest to 34. That will give you 2. So 15 times 2 will give us 30. 30 plus 4. That means 34 will give us 4 in modulo 15. Okay, so you can also use the method that with your calculator, you keep removing 15 till you have a number that is less than 15. That's your modulo. Remember, in positive number, you keep subtracting 15 from the number given. Okay, you keep subtracting 15 from the number, the modulo from the number given. Then when you get a number that is less than your modulo, then that's your answer. Okay, so let's take example 3. So here we have 104 in modulo 21. So that will give us 104 equals to 21 times which number that will give us closest to 104. Remember, the remainder must not be up to the modulo. Okay, so we must get a number that is less than the modulo. Okay, sometimes it can be exact, the exact value, which nothing is remaining, so we have it as 0. So 104 in modulo 21, 104 times 5 will actually give us 105. So we go with times 4. So times 4 will give us 84. 84 plus which number will give us 104? 84 plus 20. So 104 equals to 20 modulo 21. Okay, so we have solved about 3 examples in positive numbers in different modulos. Okay, so let us now look at negative numbers. Our fourth question is a negative number, minus 14 in modulo 3. Okay, remember what I said. Uh, if the number is positive, if you want to use your calculator, you keep removing 3 from your number till you can no longer remove 3. That's when you have a number that is less than 3, because your 3 is your modulo. But if it's a negative number, then you need to keep adding your modulo. Okay, you need to keep adding your modulo till you get a positive number, 0 or positive number. Just when you get a number that is not negative, okay, that is less than 3 but is not negative, okay, that is your modulo. Now what am I trying to say? If you have, let's say for example, minus 5 in modulo, let's say 2. So all I need to do is minus 5 plus, this is what I'll press in my calculator, minus 5 plus 2, that will give me minus 3, plus 2, that will give me minus 1, plus 2, that will give me 1. Okay, so I will stop there. Therefore, minus 5 is equals to 1 modulo 2. Okay, so that's the way to press that with your calculator. Okay, so let's solve this negative number in modulo 3. So that will give us minus 14 equals to, which number will I multiply by 3? Okay, that will give me a number less than minus 14. Less than minus 14, but the closest. So that will give us 3 times minus 5. 3 times minus 5 will give me minus 15, and minus 15 is the closest number to minus 14 that is less than minus 14. So when I get minus 15, what will I add? I will add 1 to it. So that will give us 1 in modulo 3. Okay, so that's just like when you keep adding 3 to minus 14, the first positive number or the first non-negative number you will get is plus 1. Okay, so let us look at example 5. So in example 5, we have minus 51 in modulo 18. Minus 51 in modulo 18. So what do we do there? We have our minus 51 equals to 8. 8 times which number will give us a number closest to minus 51? 8 times 6 will give us minus 48. It is not less than minus 51. 8 times 7 will give us minus 54, which is actually less than minus 51. So 8 times 7, okay? Then if we have minus 54, oh, that should be minus 7. So 8 times minus 7 will give us minus 54. If we have minus 54, what do we need to add to minus 54 to give us minus 51? Okay, which is 51. That will be 3. So minus 51 is equal to 3 in modulo 8. Okay, 3 in modulo 8. So I believe with these few examples, you can be able to solve problem or find the modulo of a positive number and a negative number. So the next thing we are going to move into is arithmetic operation in modular arithmetic. What do I mean by arithmetic operation in modular arithmetic? addition, subtraction, multiplication, and division. So arithmetic operation in modular arithmetic, okay, is a very simple thing to do, though the only place that we need to uh, explain more is in division. But in addition and subtraction and multiplication, what do we do? It's very simple. Carry out your operation, then change the number to the required modulo. Carry out your operation, change the number to required modulo. That's the easiest way to do that, okay? So that we can, I will just solve maybe one example each on addition of numbers, subtraction of numbers, and multiplication of numbers. Then we'll now move to division of numbers. That's the only place that requires more explanation. So let us take examples. Okay, so the first example we have here is 14 plus 3 in modulo 8. So they want us to carry out this operation and in modulo 8. Now, what's the shortest way to do that? Let's have our solution. The shortest way to do that is to first of all go and do your 14 plus 3, so which will give you 17. You now convert your 17 to what? To modulo 8. So 17 modulo 8 will give us 8 times 2, which is 16 plus 1. That will give us 1 modulo 8. So you can see how simple that is, okay? So whenever you have addition of two numbers, okay, all you need to do is to add the two numbers, get your answer, then change the number to the given modulo. So let us look at example in subtraction. Subtraction can give you a positive number. Subtraction can also give you a negative number depending on which number you are subtracting from, okay? So maybe that because of that, we are going to solve two examples under subtraction, then we'll move to multiplication before coming to division. So look at our example 2, 4 minus 18 in modulo 5. Carry out your operation. 4 minus 18 will give you minus 14. Minus 14 in modulo 5, that will give you 5 times minus 3 plus 1. That will give you 1 modulo 5. Okay? So the third one, if we have, let's say, 21 minus 8 in modulo 2, we have our solution. 21 minus 8, that will give you, 21 minus 8 will give you 13. 13 in modulo 2, that will give you 2 times 6 plus 1. That will give you 1 modulo 2. So you can see how simple that is. So let's move to multiplication. Let's solve one problem in multiplication. It's still the same way, okay? So in multiplication, let's take that as our example 4. If we have 41 times 2 in modulo 9, 41 times 2 in modulo 9, let's have our solution. 41 times 2 will give you 82. So that will give us 9 times 9 plus 1. That will give us 1 modulo 9. Okay? 1 modulo 9. Let's have the another example. Let's say you have 21 times 5 in modulo 7. Okay? You have your solution. 21 times 5, that will give you 105. 105 in, so 7 times, which number will give us one closest to 105? 7 times 15 will give us 105, so plus 0. So you can see this case now, there is no remainder, okay? So we can have 0, so that will give us 0 modulo 7. Okay, so this is how to add, how to subtract, and how to multiply. So let us move to division. Division is where we need to pay a little more attention on. So let us look at division before we look at some of the application of modular arithmetic. So for division, I will actually need you to pay attention here. Okay? You are asked to find 3 divided by 4 in modulo 7. What are we going to do? Please watch closely. I have my solution. 3 over 4. Okay, let 3 over 4 be equals to x in modulo 7. We are trying to find the value of x. 3 over 4. Let it be our answer in modulo 7. So what does that mean? Therefore, 4s equals to 3 in modulo 7. 4 times x, that will give us 4x equals to what? 3 in modulo 7. Now, what are we trying to do? We are trying to find the value of x that is in modulo 7. When you put it here and multiply 4, it will give you 3 in modulo 7. Now, we are going to do a lot of trial, okay, for a start. Of course, when you get used to it, you don't need to keep trying anymore to get your answer. First of all, what are the integers in modulo 7? The integers in modulo 7, 0, 1, 2, 3, 4, 5, 6. Now, all these numbers, we are going to try it as x to see the one that 4 times will give us 3 in modulo 7. Remember, when you get a number, when your 4x is higher than 7, you have to reduce it to modulo 7. Now, let's start. 4 into 0, what would that give us? It will give us 0. 4 into 1, that will give us 4. 4 into 2, that will give us 6. 4 into 3, that will give us 12. Now, 12 is higher than our modulo. Okay? So, 12 in modulo 7 will give us what? 5. Okay? 4 into 4, that will give us 16. 16 in modulo 7, that will give us 2. 4 into 5, that will give us 20. 20 in modulo 7, that will give us 6. 4 into 6, that will give us 21. 21 in modulo 7, that will give us 3. Four into 6, that will give us 24. 24 in modulo 7, that will give us 3. So we have gotten our answer. So let's go over it again. 4 times 0, of course, these are integers. So we cannot, if we have tried these whole integers in modulo 7, and we are not getting any number that is 3 in modulo 7, we say that that division does not exist in modulo 7. So let's go over this again. 4 times 0 will give us 0. Okay, that's not what we are looking for. So this is our answer now. Therefore, x is equals to 6 modulo 7. So, and what is s? S is 4 over 3 over 4. Okay, so let's go over this again. These are the integers in modulo 7. They ask me to divide 4, 3 over 4. They ask me to divide 3 over 4 equals to x, or to divide 3 over 4 in modulo 7. So I let it to be equals to s in modulo 7. Now I cross and multiply to express it as a linear equation. Then I need to find the value of x that will give me 3 in modulo 7. So I'm going to check all the integers in modulo 7. and see the one that will give me 3. Okay, so all the integers in modulo 7 are 0, 1, 2, 3, 4, 5, and 6. So I'm going to try all these as replacement of x to find out which one will give me 3 in modulo 7. So the first one, 4 times 0 will give me 0, 4 times 1 will give me 4, 4 times 2 will give me 6. Now, 4 times 3 will give me 12. If you go and do from what we have done in addition and subtraction, if you go and do uh, find 12 in modulo 7, that will give you 5 because 12 minus 7 will give you 5. So the next thing is 4 times 4. 4 times 4 will give us 16. 16 in modulo 7. When you remove 7 from 16, you will get 9. When you remove another 7 from 9, you will get what? 2. The next one is 4 times 5. 4 times 5 will give us 20. So you do the same thing I have explained here, you will get 6. So 4 times 6 will give us 24. When you keep removing 7, you are going to have 3 remaining, and what we are looking for is 3. Therefore, x is our what? X is 6, and 3 over 4 will give us 6 in modulo 7. So this is how we solve a problem in division. I'm going to solve one more problem. Look at this question here. You notice that the numerator, this is a proper fraction. So let us look at improper fraction and see whether it's still going to follow the same way. So here we have 5 over 3 in modulo 8. Now, we do the same thing that we did in the previous example. Let 5 over 3 equals to x in modulo 8. So 5, or let's have this one first, 3x equals to 5 in modulo 8. And what are my numbers in modulo 8? The integers I'm expecting to have in modulo 8 are 0, 1, 2, 3, 4, 5, 6, 7. So these are the integers I expect to have in modulo 8. So I'm going to try them out to see the one that will give me 5 in modulo 8. So 3 into 0, that will give us 0. 3 into 1, that will give us 3. 3 into 2, that will give us 6. 3 into 3, that will give us 9. And 9 in modulo 8 will give us 1. 3 into 4, that will give us 12. And 12 in modulo 8 will give us 4. 3 into 5, that will give us 15, and 15 in modulo 8 will give us 7. 3 into 6, that will give us 18, and 18 in modulo 8 will give us 2. 3 into 7, that will give us 21, and 21 in modulo 8 will give us 5. Okay, so this is the answer we are looking for. Therefore, x is equals to what? 7. Hence, 5 over 3 will give us 7 modulo 8. Now, like I said before, is it possible that none of these will give us our modulo? Yes, it's very, very much possible. And is it also possible that we will have 2 answers? Yes, we can have 2 answers. We can have even 3 answers before we exhaust the integers in a particular modulo. So in such case, you still write your x equals to 7 or, okay, so that will be your answer. Okay, so it's very much possible to have multiple answers. Okay, so this is where we are going to end the class on basic concepts of arithmetic, modular arithmetic, and basic operation. So we are going to look at application of modular arithmetic in real life situation. Maybe just solve 1 or 2 examples before we now move to problems in modular arithmetic that can, or linear equation on modular arithmetic.